Hello again. Hopefully you got up and took a break before you watched all three of these videos. But our last shape, which is our itsy bitsy square, is this is it. So for the last special parallelogram, it's a square. And what a square is now, first of all, it's all the properties of a parallelogram. And now it's a rhombus and a rectangle squished together to make a baby or to have its own shape. So if you think about it, it's going to have all congruent sides. Okay, so all the sides are congruent. It's going to have four right angles. Okay, so four right angles inside. So if you need to describe a square to your brother or sister, you have to be more specific than just saying it's a shape with four congruent sides. Because if they answer, well, that's a rhombus, they're right. So what makes a rhombus different than a square? Besides it having four congruent sides, it also has four right angles. And then more specifically, which stuff you don't study in elementary school though, is the diagonals are now perpendicular, and of course they bisect, so you could say perpendicular bisectors, but bisecting comes from parallelograms. Diagonals are perpendicular. Okay. One other thing we want to remember is now the corners opposite angles are bisected. So now let's think about this, because if I know this corner's 90, and now you're telling me they're bisected, what must these corners be? 45 and 45, and that's never going to change. Okay, so it's not like a square can have any other value than 45. And so diagonals are perpendicular, opposite angles are bisected, all sides, and then the thing would be that diagonals are congruent. Okay, and so if you wanted to describe a square, you have to be really specific. So these diagonals are also going to be the same in length. It is, like I said, the three properties of a rhombus and the two properties of a rectangle pushed together, and that's what makes a square. So right here, if I gave you this type of math problem, obviously the outsides is easy. 2x plus 1 equals 4x minus 7. Okay, it's kind of silly, but easy. Let's take a look at this. I know every corner is 90. I come here, I'm pointing to just this piece, right? And now I know since corners are 90, but the corners are bisected, 7y plus 3 has to be 45. I'm going to move over. I'm going to get 42, and y is 7. Something I want you to consider. I don't know if I have another problem. I do. Okay, let's do this problem. Please pause the video and try it as much as you can first. If I start to go through this, I see this is 15. That's what they're talking about. It's 15, JG. It tells you in the directions. So that means every diagonal length's 15. There's no values because you need to know every corner's 90 and inside the diagonals are 90. So if I say EJF, I know they're talking about 90. I know JFG is 45. Okay. FH is going to be the entire diagonal length, and EJ is going to be half of that diagonal length, so 15. Now we get to FG, which is out here, and here's something I want you to realize. In any square, we're only going to have either a large right triangle, right? And these corners are going to be 45. Or I'm going to have a small right triangle in here, and these are going to be 45. So no matter what, you do have to pay attention to the sidelines. But what I want you to realize is every triangle's a 45, 45, 90 triangle, which means I just want to put out there, I'm never going to ask for decimal form. So I want always it to be in radical form because it's a 45, 45, 90. So here's the 90 degree. I'm going to do this one. So I'm doing F, J, G. So sometimes it helps to label. I know that FG is 15. I know this corner is 45. And I'm looking for this. So now it's what you can remember about 45, 45 is this is going to be 15, 15, 15, 15 root 2. So I'm telling you, just as a heads up, I will never ask for a decimal in a square because it's always going to be a special right triangle. It's always going to be a 45, 45. Had you done it this way too, you could have used this right triangle here, and then you would have known the diagonal was 30 and would have just had to take 30 equals x root 2 and divided by root 2 and got 15 root 2, I'm sorry, 30 root 2 over 2, and then that would have came to 15 root 2. So just so you know, it wouldn't matter which one we looked at, and you'll always get a exact answer. Awesome. We're done. Don't forget, again, I'm showing it one more time. Your flow chart should be filled in. You should have these. You shouldn't have trapezoids or kites yet, but you should fill these in. This is going to be your easiest go-to to know your properties.